Hey folks, thanks for setting up your notes. We're going to try a few problems together. I just wanted to start with this image because there is a ton of information in this section. I don't think you could listen to me long enough for me to get all the information that's in this section to you and you to copy it all into your notes. So here's what we're going to try. I'm going to go over a few of the properties, but I want you to be aware that we do have a textbook, right? And the textbook is online. And so I'm copying those problems that you just saw, those three problems, right, from our textbook. And they're going to be digitally, on McGraw Hill, where you type in your answers in a little, answer box and all that kind of stuff. But they're the same ones as the ones that are in the book. The ones that I'm choosing are the same ones as the ones that are in the book. So when we look back here in section 6, let's go back to the start of the section. They start with trapezoids, and they talk about isosceles trapezoids a lot on this page. So let's look over at our notes. Trapezoids are the second object that we have set up in our focus notes because we looked at kites on Friday in that Desmos activity. So if I switch over to the Desmos activity real quick here, it looked like this. Remember, we were investigating the diagonals of like a parallelogram, and we're going to talk about this in class. I'm going to review a whole bunch of these, but kites were right here. And you can see in a kite, there's two sides that are equal, and then another two sides that are equal. And the sides that are equal are consecutive with each other. They share a vertex. They're not across from each other. The ones that are across from each other, like in a parallelogram, those are the ones in a parallelogram that are congruent. The ones that are opposite from each other. But in a kite, it's the ones that are consecutive. So we could start in our notes with a kite real quick, and then we can get to the trapezoid, I suppose. But let's just mark these like this: 1, 2, and then 3, 4. Okay, so let me see if I'm making this clear. When we look in our textbook, here it is right here. They start with trapezoids, but I put in your focus notes kites because that's what we looked at a little bit on the Desmos activity. So here's what a kite is. There are two consecutive sides that are equal. It does say their diagonals are perpendicular, right? And it says that exactly one pair of opposite angles are congruent. So, like I was saying, there's a ton of information in this section. So when you get a kite on a homework problem, I want you to be aware that you could have the textbook open. You could be looking at some of their examples if I don't cover enough information here. But what they're saying is that the angles that are going to be equal are the ones that are between the two sides that are different lengths. So you might have like a short side and a longer side, short side and a longer side, and it's the angles that are between those two. They also said, if you remember what it was talking about in there, that the diagonals are perpendicular to each other. Okay, and so this is going to be an opportunity for them to quiz us on Pythagorean theorem. When you got a right triangle, Pythagorean theorem quite often comes up, one of the most important topics in our geometry studies. So I'm gonna darken in this little triangle right here. This is quite often what they ask in homework questions. I'll give you a couple sides, and you have to find an unknown side. The other thing that's true in these diagonals is that the one that's going between the two different side lengths, that diagonal right there is bisected. That's the one that's bisected. So this piece is equal to that piece. But like I was saying, I could talk and talk and talk about these objects, and you could jot a whole million notes on them. But I think the best thing to do is when you come across a homework problem, you could open up to this digital page 123, or in the textbook, it's page 103. And you could look at some examples here. You could look at these properties. You could add some more notes as you're doing the homework problem, right? So you can see here, Pythagorean theorem, right? They had 6 and 12, and they had to find a hypotenuse. So there's just gobs and gobs of information in there on how to do these problems. Now, let's go back to trapezoids. And I'm going to go back here because there are some things that I think I could review here with trapezoids. So some vocabulary, like these are the bases, the ones that are parallel. See those little arrows? Now, does the trapezoid have to be where the bases are the ones going horizontally and the legs are kind of going at a diagonal here? No. I made where did it go? On GeoGebra, I made a trapezoid and I made the bases go kind of vertical. So like if I rotate this around, I could make it look more like the trapezoid that you often see, where you have the parallel sides as the top and the bottom parts. these are still the bases, no matter what direction it's facing. The ones that are parallel are the bases. So these two here, BA and E, whatever the heck that is down there, ED and BA are the bases, and then EB and AD are the legs. So here are the legs. And you got to pay attention to all that information. Where are the bases? Where are the legs? Now, so the two parallel sides are the bases. I'd like you to add that to your notes. Our bases. Oh boy, that is horrible. I got to erase that. I can't take that. So the two. I can't erase that because I didn't lock these letters down here. So let's just put this up above. Are the bases. Okay, the two parallel sides are the bases. And the other two sides are the legs. Okay, so two parallel sides are the bases, and the other two are the legs. The other two are legs. Okay, so let's put leg here and leg over here, and then base here and base down here. That's important because they'll tell you which ones are the bases, and they'll expect you to know, oh, those are the parallel ones. Now, when you have parallel lines, and I don't know if you remember this from last year or not, but if they're cut by a transversal, this angle right here and this angle down here are called same side interior angles. They are supplementary. So I want you to put the word sup, or the abbreviation for the word supplementary, or you write out the whole word in there, supplementary. I can't fit it in there. And so those two angles are supplementary. Like if this one was 100 degrees, this one down here would be 80 degrees. So that's the kind of deductive reasoning skills that they're going to ask you about. So you could say, consecutive angles. See, there's just so many words that you got to write down in your notes that I think it might be best for you to look in the section when you come across an isosceles trapezoid, or when you come across a trapezoid in general. Consecutive angles in a trapezoid are supplementary. And we're going to look at some examples here in just a second. Okay, so supplementary. I don't think we had that supplementary. And then it says if the legs are equal, then you have an isosceles trapezoid. So let's mark them equal now. Let's say this one's equal to this one. Now, what would that mean for my base angle? So these are called base. Let me put down, in a different color. Base angles are the ones that are, formed by the leg and the parallel line, and a leg and the other, the line, the same line that was making up this one over here. So the ones that are between the legs are the base angles. So these are also base angles up here too. Okay. And the base angles, if you had an isosceles trapezoid, are going to be equal. Are equal if isosceles trapezoid. Okay. Oh boy, man. Like I said, I feel kind of overwhelmed with the amount of information that's in this section. So if the legs are equal, then you have an isosceles trapezoid, and the base angles, that's what I was thinking you put right here in that bullet. Now, the mid segment is joining the midpoints of the legs. So if I put the mid segment in here, okay, so that's the mid segment, it joins the midpoints of the legs. Midpoints of legs. And it's the average of the two. It's the average of the two bases. So it's average of the two bases equals the average of two bases. So what is an average again? It's where you add them up, add both bases, and divide by 2. So add both bases and divide by 2. So let's look at some examples now. Am I saying these notes are super solid, super complete? No. I'm asking you, let me just say it one more time, to consider opening up the textbook, and then you're going to, go to wherever you need to go. Like, oh, we're talking about isosceles trapezoid. So is this a helpful example? We're going to talk about mid-segment. So is this information right down here? See how it says it's half the sum of the lengths? That's the same thing as taking the average, like adding the 2 and dividing by 2. 2 is the average, right? You're adding the two bases and then divide by 2. Sorry, that wasn't clear the way I said that. And then, here's an example on how to get the mid segment and all that kind of stuff, right? So I'm going over here. I'm going to try a couple here with you, right? So let's look at those first 3 problems here. And it says a bunch of information about the bases. So these are the bases here and here. And it tells us one of the bases is 2x minus 2. So 2x minus 2. And the other one is 2x plus 6. 2x plus 6. Now, I think this is kind of information that you're not going to use right at the start. They tell us it's isosceles also in here. See that word right there? So that means the legs are equal to each other. So this next piece of information is more important than what they just told us about the bases. So WZ is 4x plus 5 and XY is 5x minus 3. So we're going to set those two equal to each other, right? Almost every problem we've had with deductive reasoning is, well, how am I going to set up my equation? And so once you see it's isosceles, the legs are equal to each other, you're going to set 4x plus 5 equal to 5x minus 3, and you're going to solve the algebra for that, right? So we're going to subtract 4x from both sides. We're going to add 3 to both sides, and we end up with x equals 8. Okay, so that's, we've just proved that x is 8. Now it says find angle Z if W is 106. So this is 106. Well, angle Z is that consecutive angle between the bases. So it's got to be supplementary. So this one down here has to add to that one to give us 180. So that would be what, 74 degrees? Or you could, let me write some work down here for you. 180 minus 106 is 74 degrees. Okay. Now it says find the perimeter of the front face. Well, we need to take the 8 and plug it in. So 8 goes in here. So we got 2 times 8 plus 6. Let's see, that's 16 plus 6 is 22. And 32 plus 5 is 37, right? I plugged 8 right there. 8 times 4 is 32, plus 5 is 37. Well, this one's got to be the same over here. It's got to be 37, and it is. 8 times 5 is 40, minus 3 is 37. If I put 8 in here, I get 16 minus 2 is 14. So now we add them all up. 14 and 22 is 36 plus 74 is going to be like 110, I think. So you check it, make sure that I'm doing that arithmetic right, but I think it's 110, 74, 80. Yeah, I think it is. So let's look at this one right down here. Find the measure of each thing that they're asking for here, right? So angle T, how big is angle T? Well, it's isosceles, so angle T has to be the same as this base angle right over here, so 60 degrees. What would this angle, just out of curiosity, can we do that? Can we find this angle over here? Well, it's got to be supplementary with that one over there, so it's 120 degrees, okay? How about angle Y? Oh, here we go. Here's our supplementary quiz right there. So let's see, that would have to be 112 degrees, I think, so that we'd have 180. You could do 180 minus 68, and you get 112, I think. Hey, wow. There is so much information. Just as a reminder, how do you open up the textbook again? You go to Clever, you go to McGraw-Hill. When it opens up, your options, you want the option on the right. You don't want Alex, of course. And come on, open it up, computer. When you open this guy up right over here, one of these little icons right here is going to say Student Edition, Integrated 2. When you open that guy up, you just have to navigate to the right place to get to the right spot. You can see mine, since I left that spot, it's still there. But if yours is in a different place, you just open up that little deal right there. We're in chapter 2, right? Module 2, I guess they call it. And then you got to find module 2, section 6 on trapezoids and kites. You can just click on that guy. It's going to take you to page 1. Remember, it's in dual page. So if you just go to single page, I think that's a little easier to see. And this is on page 99, but it goes all the way, through to like 125. So anytime that a math textbook has like 6 or 7 pages of information, man, that is a lot of stuff to put in your notes. Now, are your notes complete at this point right here? I don't really think so. I think you're going to put some examples down here, you're going to do some homework problems like those homework problems that we just did, right? On this page right here, I'd like to see a drawing down, and then that would be, over on that other page over there. So let me try that real quick just to see if I'm making this clear. Like you'd have problem number 2 looking like this, right? And let me see if I can get a copy of that guy right there. So I'm going to cut it and I'm going to put it over on this page. So right down below here, you're going to have, here's problem number 2 in my homework. Ladies and gentlemen, thanks for taking some notes and watching my video. I really appreciate you. You're doing fantastic. Keep up the good work. I'm wanting to help you out, so I'm just going to be walking around seeing if I can help anybody out. Thank you.